Can we fabricate the future from the probabilities of past data? Or might we get stuck in an endless loop of history repeating itself? How will prompting alter our perception? What types of aesthetics will large language models bring to the world? In what ways will technologies like ChatGPT affect notions, principles, and styles for the coming decade? Artificial Worldviews is a series of inquiries into the system underlying ChatGPT about its descriptions of the world. Utilizing prompting, data gathering, and mapping, this project investigates the data frames of artificially intelligent systems. At the beginning of the project, I asked GPT 3.5 about what kind of categories of knowledge exist. What came back are lists of topics and subtopics. These registers resemble short stories by Borges or Kafka, strange categorical creatures of inclusion and exclusion. 2 prompts were designed to generate data for each combination of topic and subtopic. The first gathered names, categories, descriptions, and relations of key figures. The second focused on objects, things, and places. This process resulted in 1,800 prompts and a final dataset containing nearly 19,000 items. Here is an example of the returned data from the topic with the least items, nature. For each topic and subtopic, I make 2 requests, one for humans and one for objects, places, and ideas. The system returned a dataset for each request. The dataset contains an array of related items. For each category of knowledge, such a hierarchical network structure now exists by prompting data. Most of what is called artificial intelligence at its core are giant spreadsheets of tokens and vectors, of words and numbers. Machine learning procedures by turning symbols into high-dimensional numerical representations. In this context, high-dimensional means that hundreds of numbers represent a word fragment. The essence of these systems, as words and vectors, seems simple, but machine learning draws heavily on the fabric of reality. The layers above the computational calculations are where the fault lines emerge. One way to imagine the data returned from GPT is as a hierarchical network structure in which topics connect to subtopics, which connect to items and related items. Within a force-directed layout, points, items, and related items repel each other while connections draw points together. Through this computational process, a map of all returned data items of GPT's prompting emerges. Items with many connections draw closer, while unrelated objects draw further apart. The final map consists of 4 layers. The 31 fields are placed on the map through a polynomial regression analysis. Similarly, the 425 subfields are located using the same algorithm. The third layer consists of the 7,880 items. Their size is determined by the number of times GPT named the item. The last layer consists of the 24,416 related items. What you see here are each of the 31 fields, their subfields, and items of the knowledge map. Throughout this section, I will go through several of the fields, explaining their positioning and meaning within the graph. The field of art spans a vast region of the map, from virtual reality, on the bottom left, to the cluster of fashion, including Coco Chanel, Karl Lagerfeld, and Fashion Week on the upper right. Astronomy occupies a region on the center-left outskirts of the map. At the same time, a number of items are located much more central, such as Isaac Newton, Albert Einstein, Elon Musk, Jeff Bezos, and Rachel Carson. While education clusters at the center bottom of the map, it has one strong outlier at the top, namely music. From this perspective, music draws education and the arts together. One of the most unexpected positions holds geography to me. It is located at the center of the map and draws together a vast array of items from water, animals, wildlife, to renewable energy, globalization, the United Nations, culture, language, to religion. Law is split into two areas, while the left area contains legal terms and topics such as witnesses, judge, or the United Nations. The bubbles on the right are mainly concerned about climate change, like endangered species, sustainable development, or renewable energy. Each field holds stories to explore in the form of outliers, regions of interest, and unexpected relationships. The closer the points gather around a term, the tighter the network is structured. The larger the spread is, the more a field connects to other fields. In addition to examining the broader fields of knowledge, it is possible to focus on specific points within the map. The following list presents the 100 most frequently named items, along with their respective fields and subfields. The list encompasses a diverse range of subjects from the god Thor to the environmentalist Rachel Carson. While the list is predominantly populated by Western male humans, 3 of the top 4 named individuals are female, apart from Aristotle. Notably, only a small fraction of the list comprises non-human entities, including forests, climate change, urbanization, the matrix, water, oceans, technology, and coral reefs. The rankings indicate the extent to which a given item is known. To be ranked highly, ChatGPT had to name the item in as many of the 1,800 prompts as possible. For instance, Greta Thunberg is named in the fields of environment, geography, science, and travel. Conversely, the Internet is named in the fields of education, history, languages, and technology. The number of fields and subfields in which an item is named determines its ranking. After inquiring GPT about knowledge, I proceeded to create a second map, utilizing the same process as before, but this time focusing on power. The relationship between knowledge and power is symbiotic, whereby power reinforces knowledge and knowledge produces power. Consequently, the two maps are linked, representing two distinct yet complementary aspects of synthetic data of large language models. Similarly to the knowledge map, we can now investigate the fields of power and their structures of closeness, spreading, and clustering. While it is intriguing to analyze the network structure, it is as important to ask what is not drawn onto the map. Rather than asking what is represented, we can inquire about the undistinct. What might power be otherwise, that GPT did not name? What is the media negativity of the diagram? While geography is at the center of the knowledge map, social power and knowledge are at the center of the power map. The natural, environmental, and non-technological only exist on the outskirts of the map of power. What is visualized here are the 100 most frequently named humans, objects, places, and things within the map of power. Their related fields, subfields, and relationships become visible. In contrast to knowledge, power is considerably more diverse. While the most frequently named items in the knowledge map are predominantly Western male individuals, the power map presents a markedly different narrative. There are equal numbers of men and women in the top positions, In addition, media concepts such as the internet, the printing press, propaganda, and social media all appear at the top of the list. The three most frequently named items on the power map are Nelson Mandela, the internet, and Mahatma Gandhi. The concept of artificial worldviews represents a new mode of scientific inquiry into the world through the distorted lens of large language models. These systems permit the augmentation or generation of datasets that extend beyond the mere representation of the world and the training data. They encompass the political embedding of the system, the infrastructures and mindsets of the trainees, and the corporate identities involved. In this world, the concepts of truth and certainty are absent, as the dynamics of the various identified layers of computation, data, labor, and material remain unclear and in constant flux. Concurrently, the maps serve as a representation of the conglomerate of these forces. The mise-en-scene of planetary computational datasets, economic interests in leading the latest technology race, and obscured political settings of inclusion and exclusion through clickwork and model adjustments.